Hello, beautiful people, and welcome. In today's video, we are going to be graphing exponential functions. Now, if you are in my class, we have done an introductory lesson on this. This is going to be some examples to further your understanding of graphing exponentials. Let's go ahead and start with an example of graphing f of x is equal to 5 to the power of x. Now, what makes this an exponential function is that we have an x in the exponent spot. To evaluate things with an x in the exponent spot, we're going to create a t-chart. And when we do this t-chart, notice that we do have a spot that's a little larger in the middle, a little table here. Here are going to be our x's. Here are going to be our f of x. Now, what this means is that we have our input of x and we have our output of f of x. Now, remember, f of x is just another way to say y. The first thing you're going to do is you're going to choose your x values. Domain is not given to us. Our inputs are not given to us. So we're going to select some negatives and some positives. So I'm going to start with a -3, a -2, a -1, a 0, a 1, a 2, and I'm going to continue to a 3. So I'm going to extend my lines here. The first thing you're going to do after you create your x values, you're going to take your given function and you're going to copy and paste right next to your x's. So I'm going to write 5 to the power of x, 5 to the power of x. I'm just copying and pasting. Nothing changes here. We're just writing out our function over and over and over again, followed by an equals. Next, we're going to be replacing our input of x. So notice we have an x, 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 and x. But if we look on the left-hand side, we notice that we have different x values. So in our x spot, in our exponential spot, we're going to be rewriting that 5, but then putting an exponent of whatever exponent we have. So we have 5 to the power of -3, -2, just kidding, 5 to the power of -2, almost messed up there. Then we have 5. I'm just going to write 5 so I don't forget that 5 is my base. And now I'm going to be copying and pasting my exponents, my inputs of -3, -2, -1, 0, etc. From here, this is where the confusing part happens. You are going to evaluate what these are. If you see a negative exponent, that means flip the base. So 5 becomes 1/5. And you're going to make the exponent positive, which means that I have 1/5 times 1/5 times 1/5. I'm going to zoom in here just a little bit so you guys can see this better. There it is. Again, what happens is if you have a negative, flip the base, write it out that many times. So if I have a base of 5, negative exponent, flip it, it becomes 1/5, take the reciprocal. Then I have a 3, that means I'm going to be writing 1/5, 1, 2, 3 times. Now you can use a calculator here or you cannot use a calculator here, but what we're going to do is we're going to multiply 1 times 1 times 1, which is 1. Then we got 5 times 5, which is 25, times 5, which is 125. So our input of -3 gave us an output of 1/125, so 1/125th. Now you're going to do that over and over and over. So let's try this again. Is our exponent negative? Yes. What do? flip the base. The exponent becomes positive. We're going to write that base 1 twice, 2 times. And the reason we write the base twice is because we have an exponent of 2. 1 times 1 is 1. 5 times 5 is 25. Is our base negative? Yes. What do we do with a negative base? What do we do with a negative exponent? We flip our base. Now this one has an exponent of 1, so how many times do we write our base? We write our base once. Let me see if I can make this a little brighter for you. Tiny bit brighter. Let's see if that helps. There it is. So we write the base of 1/5 one time, which is 1/5. Now, this one here is supposed to be an easy one if you remember your exponential properties. Anything to the power of 0 is 1. So this one, all you have to do is write the number 1. Next, we have 5 to the first power. So what's our base? 5. Is this a negative exponent? No. So we write 5 how many times? 1 time. Next, we have a base of 5, an exponent of positive 2. Is that negative? No, it's positive. So how many times are we writing 5? Twice. 5 times 5 is 25. Next here, not negative. Don't flip anything. 1, 2, 3. We write it 3 times. We got 25 times 5, which is 125. After we write these out, what is created are points of an x and a y, an input and an output. So our first point is -3, 1 over 125. Our second point is -2, 1 over 25. Third one is -1, 1/5. Then we have 0 and 1, 1, 5, 2, 25, and 3, 125. Now, if we take a look at our graphing, we're going to first start out with an asymptote. Now, we haven't really mentioned an asymptote in this video, so let me zoom out just a little bit. An asymptote comes from your k value. Now, I don't have a k anywhere in here. A k value is a number that is at the end of your equation. So for us, our k value would be here at the end of the equation. Now, since we don't have a k, that k for us is 0. This is called an asymptote. Let me spell that out. And an asymptote is a dotted line that we do not touch and we do not cross. So let's go ahead and graph this one here. I'm going to do a quick example. If you're doing this in your notes, try your best or use graphing paper. We have an asymptote at y equals 0. So here's our y-axis. We're going to find 0. There it is. And we're going to draw a dotted line going past what is given to us. Otherwise, we won't be able to see it. Now, this is the line we do not cross, we do not touch. Next, I'm going to cheat a little bit here and look at our points. So we have -3 and 1 over 125. Now, I'm going to cheat and use a calculator. 1 over 125 is very close to 0, but it's not 0. I cannot graph that. I'm going to choose something larger. So let's try 1 over 125. That's still pretty small. I can't graph that. What about 1/5? I can try my best to graph that. I know this is going to be close to 0. So that is -1 and 1/5. So I'm going to put it right there. Is that where it's actually? Probably not, but we're going to try our best. Then we got 0 and 1. Here's 0 and there's 1. Next, we got 1 and 5, 1 and 5. And then if you look, our next point is 2 and 25. I don't have a 25 here. I can guesstimate, so I have 19, Maybe there's 20, 21, 22, 23, 24, 25. So maybe about here is 125. Now, for an exponential, you either have a growth or a decay, depending on your b value. So we're going to try our best to connect this smooth curve. Now, remember, asymptote you do not touch. So when you get to your asymptote, you need to leave a gap and give me half an arrow. And then this one we're going to extend and give me a full arrow. Because we are going uphill, this is considered an exponential growth. And that's how you graph. Let's go ahead and try to do another example. Let's do one maybe with the k value and see how that is going to change our overall function. Let's stay with the growth. Now, if you take a look at the equation, a growth versus a decay will depend on your b value. Your b value is your base. So let's give it maybe a 2x, and let's give it a k value of, I don't know, let's do a -4. So when we look at the equation, the number at the end, this is your k value, and this is your asymptote. And your asymptote is going to be your y equals, for us it's -4, dotted line that we will not touch or cross. Let's go ahead and do our t-chart. Just like we've done before, nothing changes on our work. I am going to leave the middle. Should call it a table, not a t-chart, but that's okay. F of x. And this is our work. The first thing you're going to do is you're going to copy down the equation and give me some x values. So I'm going to choose the same x values. So we have -3, -2, -1, 0, 1, 2, and 3. Copy down your equation. Now to save space, I'm going to do a little line here for my x values. And I'm going to copy that over and over. Oops, that should be a minus. Let's make that into a -4, not a +4. So it should be the same. Can I save it? I think I can save it. A -4 should be the same as what is provided to us. And again, what are these random lines right here? Those are going to be your x spots. I'm just opening up x so we can put a number and input in there. And we're almost done here. Perfect. Equals, 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 equals. Okay, so now we're going to take a look at our x values. Remember, these are our inputs. And I'm going to input -3 for x, -2 for x, -1, a 0, a 1, a 2, and a 3 for x. Next, I'm going to evaluate what each of these are. So I'm going to evaluate the base and the exponent, base and the exponent. Notice I'm going to ignore that -4 first. I'm just going to do base and exponent first. And then after I get that value, then I will subtract by 4. So let's go ahead and start. Is the exponent negative? Yes. What does that mean? That means I flip the base. I put brackets here. You can put parentheses. And that's going to bother me. Let's do parentheses. So we have flip the base, keep the exponent. Here's your -4. Okay, what does that mean? That means that I got 1, 2, 3, and we have that -4. However your exponent is, that's how many times you write your base. Now, if your exponent is negative, that means you have to flip the base. I'm going to, again, evaluate that a little later. Okay, is your exponent negative? Yes. That means you flip the base, keep the exponent, but make it positive. So how many times am I writing my base? I'm writing my base twice. Then we have that -4. Is my exponent negative? Yes. Flip the base, write the exponent, but positive. How many times are we writing the base? We're writing the base once because our exponent is 1. Anything raised to the 0 power is 1. Is the exponent negative? No. That means you keep it. How many times am I writing it? I'm writing it 1 time. Is my exponent negative? No. Keep the base. How many times are we writing it? Twice. Is my exponent negative? No. How many times are we writing it? 3 times. Now, dealing with the whole numbers here is going to be easier than dealing with these, but it's okay. We can use a, let's see if now it's too bright. We can see if it is doable on a calculator, or we can do it by hand. So we have 1/2 times 1/2 times 1/2 minus 4. Now, if you take a look here, we do have a decimal. Decimals are not allowed, so we're going to do second, PRB, and we have a mixed number. And mixed numbers are also not allowed, so we're going to have to convert. And that's okay. So equals, we got a -3 7/8. That means we're going to have -8 times 3 plus 7, which gives us a 31/8. Let's see if we can get a prettier fraction. 1/2 times 1/2 minus 4, second PRB, and we get -3 3/4. Okay, again, convert that. 4 times 3 plus 3, and I get 15 -4. Okay, still not pretty. So let's do 1/2 minus 4, second PRB. And if we saw that decimal, we saw that it was going to be 3.5. So 3 times 2 is 6, plus 1 is 7, -7/2. So we're getting a little bit better. Now we're dealing with whole numbers. 1 minus 4, minus 4 is a -3, and we can just carry that -3 here. 2 minus 4, that's a -2. Oh, careful here. So we got 2 times 2 minus 4, which gives us 0. So I'm liking these numbers a lot better than the first one we got. 2 times 2 times 2 minus 4 is 4. Okay, so what does that mean? That means we've created an input and an output for our function. We got an input of -3, an output of -31/8, an input of -2, an output of -15/4, an input of -1, an output of -7/2, an input of 0, an output of -3, an input of 1, an output of -2, an input of 2, an output of 0, and an input of 3, an output of 4. And so these are the ones that you're going to be graphing, an input and an output. Let me get another sheet of graphing paper. I'm going to shift this a little off to the side. And we're going to sketch. Okay, what's the first thing we do when we graph? We're going to look for that asymptote. Okay, what's our asymptote? What's our k value? Our k value was -4. So on my y, I'm going to go down and find -4. That is the dotted line that I'm going to create. Make sure you go past what is provided to you so we can see it. And that's the line that the curve is going to be approaching. Okay. Next, we're going to use our points. Now, obviously, there's going to be some points that I won't be able to graph, like -3 7/8. I can't graph that. There's no way. This one, it's not worse, but I think I can graph 3.5 negative. So let's do that one. I can do -1 and -3.5. -1, here's -3 and 3.5. Next, I can do a 0 and a -3. 0, -3. Then I can do a 1 and a -2. A 2 and a 0. And a 4, just kidding, a 3 and a 4. 3 and 4. Curve, Do not touch that asymptote. Make sure there's a gap. Curve up with an arrow, and this is your line. So if you notice the difference between example number 1 versus example number 2, having an asymptote of 0 versus having an asymptote of -4, it shifts the line down, or the curve down. It shifts the asymptote line down, therefore shifted the curve down. Now you can see the pattern here. We're going up, up, up. We're going up, up, up on both. That means this is also an example of an exponential growth. And if we take a look at our equation, f of x is equal to b to the x power. If this b is greater than 1, we're going to have growth. So for us, we had a 2 in our example. So our example was f of x is equal to 2 to the x power minus 4. We're taking a look at this 2. 2 is greater than 1, so we're going to have a growth. If we take a look at example number 1, our example number 1 was f of x is equal to 5 to the power of x. We're going to take a look at that 5. 5 is bigger than 1, so once again, we're going to have a growth. You're taking a look at what is your b value, and if that b value is greater than 1, you're going to have a growth. Let's do one more example, and this time let's do a decay. So let's do a b value that's smaller than 1, but greater than 0. Example number 3. I'm going to keep the asymptote at 0, so I will not be giving you a k value. F of x is equal to, let's make it 1/4 to the power of x. Give me a table, extra space on the inside for some work. We have our input of x and our output of f of x. We're going to give myself a little bit of space here. Put in, and I'm always using the same numbers like -3, -2, -1. We want some negatives, we want some positives, we want 0. And now we're going to copy the function just like we did. Now you have a choice here. This is our third example. You can write x, or you can just leave x and then put in the x value. That's what I'm going to do. Instead of writing x, I'm going to just write 1/4, and then I will go back and put an input of my x values, my inputs. So I have an x value, here's x. I have an x value of -3. I have an x value of -2, of -1, 0, of 1, of 2, and of 3. Let's go ahead and put equals on this. And we're going to continue to ask ourselves, is the exponent negative? If the exponent is negative, you're going to flip the base. Now you have a choice to make. You can flip it as 4/1 and make it positive, or you can flip it as just 4 and make the exponent positive. I'm going to do just 4. How many times are we writing our base? 1, 2, 3 times. Is the exponent negative? Yes. What do? Flip the base. Again, you have a choice. You can write it as 4/1 with a positive, that should be a 2, with a positive exponent, or you can just simplify that to 4, which is what I'm going to do. How many times are we writing our base? Twice. Is the exponent negative? Yes. What do? Flip the base. Make the exponent positive. I'm going to simplify that to just 4. How many times are we writing our base? Once. Remember, anything to the power of 0 is automatically 1. Is the exponent negative? No. Do I flip the base? No. So I'm going to write my base how many times? Once. Is the exponent negative? No. Do I flip the base? No. How many times am I writing my base? Twice. Is the exponent negative? No. Do I flip the base? No. How many times am I writing my base? 3 times. 1, 2, 3. Now again, with the help of our calculator, 4 times 4 times 4 is 64. 4 times 4 is 16. This is just 4. I'm going to draw arrows to help me know which one's my output. This is just 1. Here we had just 1/4. There's nothing to do here. Here we do. 1 times 1 is 1 on top. 4 times 4 on the bottom is 16. And we already know what 4 times 4 is. That's where I'm getting those numbers. 1 times 1 times 1 is 1. 4 times 4 times 4. 4 times 4 times 4 is 64. Let's write out our inputs and our outputs. We have an input of -3, an output of 64. Input of -2, output of 16. Input of -1, output of 4. Input of 0, output of 1. Input of 1, output of 1/4. Input of 2, output of 1/16. Input of 3, output of 1/64. Let's go ahead and graph that. This will be our last example. Get some graphing paper. And like I mentioned, on this example, we do not have a k value. So we're taking a look at what is at the end of our function. If there is nothing there, that means our k is 0. That means our asymptote is at y equals 0. If there is a number at the end, that means your asymptote is going to be different. So we're going to start our graphing, finding on our y a 0, and making a dotted line, go past what is given, so our reader, as in your teacher, could see where your asymptote is. Otherwise, it blends in and we can't see it. Then we have our points. Let me shift my paper. Things like -3 and 64, I don't have 64 on here, so I'm going to shift. I do have a -2 and a 16. So I'm going to find -2 and I'm going to find 16. Then I have a -1 and a 4, a 0 and a 1, a 1 and a 1/4. So I can guesstimate where that is, somewhere here. I know you guys can't see it, but I'm looking at my numbers. I can't graph 2 and 1/16. That's too small. Same with 3 and 1/64. So this is what I have. I'm going to carefully connect, smooth curve. Do not touch that asymptote. I'm going to shift my paper a little bit to help me get close to that asymptote with half of an arrow. Bring this a little higher with an arrow. So full arrow, half of an arrow. And this, you can see, is going downhill. So as it's going downhill, this is called exponential decay. So if we were to take a look at our equation, our b value, our base, was smaller than 1. So if your base is between 0 and 1, think fraction, then you will have what's called a decay. You're going to be going downhill like this. So for us, we had a 1/4, and we know that 1/4 is between 0 and 1. Think of a fourth of a pizza. So that means we're going to have a decay. All right, beautiful people, that is it for me. Thank you so much for watching. Enjoy the rest of your day.